Hi, this video is about ideal gas law and stoichiometry chemistry practice. To solve such a question, where we have to convert the volume to number of moles without using density, we must use ideal gas law, which is PV equal to nRT. Welcome to schoolaa, your online school. You may check your understanding by solving the individual questions, and you may check the description box for useful links. In the description box, you will find a link for a video about volume stoichiometry exercises, where we used to convert volume to mass using density and mass to number of moles using the periodic table, and then use the number of moles in the mole ratio. And vice versa, if we want to convert number of moles to volume, we have to convert number of moles to mass first, then mass to volume. But in our case, we don't have density, so the relation between volume and number of moles, we're going to use ideal gas law, which is PV equal to nRT. Something to mention before we solve our first exercise is that we are using ideal gas law to convert between moles and volume, since we are not working at standard temperature and pressure. I will make a video in the future to cover how to deal with stoichiometry at standard temperature and pressure. How many grams of lithium are needed to produce 1.6 liters of hydrogen gas at 25 Celsius degrees and 90 kilopascal? To find the number of moles of lithium, we should find the number of moles of hydrogen first. To do this, we use the ideal gas law. So we write the given, volume is equal to 1.6 liters, temperature is equal to 25 Celsius, we add to it 273 to convert it to Kelvin. As you know, to apply ideal gas law, the temperature should be in Kelvin, which is equal to 298 Kelvin. Pressure is equal to 90 kilopascal, and since the pressure is in kilopascal, so the proportionality constant is equal to 8.314. We write the ideal gas law, PV equal to nRT, then number of moles is equal to PV divided by RT. We replace the variables by their values, we do the math, we find that number of moles is equal to 0.06 moles of hydrogen. Then we use the number of moles of hydrogen to find the number of moles of lithium using stoichiometry. We start by 0.06 moles of hydrogen, we multiply it with a fraction. We put moles of hydrogen in the denominator and moles of lithium in the numerator. We get the coefficients from the balanced chemical equation, 2 next to moles of lithium and 1 next to moles of hydrogen. Then we multiply with another fraction to convert moles of lithium to grams of lithium. We put 1 next to moles, and next to grams we find its molar mass from the periodic table, which is 7. We cancel the similar units between numerators and denominators. We multiply all numerators together, we divide them with the denominators, and we get the answer equal to 0.84 grams of lithium. Let's have another exercise. You may pause the video and solve it by yourself, and then play the video again to check if your answer is true or not. How many liters of carbon dioxide are produced at 20 degrees Celsius and 1.2 atmosphere by the decomposition of 50 grams of calcium carbonate? Here we should find the number of moles of carbon dioxide first through stoichiometry, and then we apply ideal gas law to find its volume. So we start by 50 grams of calcium carbonate, we multiply it with a fraction to convert it to moles. We put 2 grams of calcium carbonate in the denominator and moles of calcium carbonate in the numerator. We put 1 next to moles of calcium carbonate, and next to grams of calcium carbonate we find its molar mass from the periodic table. The molar mass of calcium carbonate is 100. Then we multiply with another fraction to convert moles of calcium carbonate to moles of carbon dioxide. We put moles of calcium carbonate in the denominator and moles of carbon dioxide in the numerator. We get the coefficients from the balanced chemical equation, 1 next to carbon dioxide and 1 next to calcium carbonate. Then we cancel the similar units between numerators and denominators. We multiply all numerators together, we divide them with the denominators. So we get the number of moles of carbon dioxide is 0.5 moles of carbon dioxide. And now we apply ideal gas law to find the volume of carbon dioxide. We write the given, temperature is equal to 20 degrees Celsius plus 273 to convert it to Kelvin. It's equal to 293 Kelvin. Pressure, it's equal to 1.2 atmosphere. number of moles is equal to 0.5 moles, and since pressure is an atmosphere, so the proportionality constant it's equal to 0.0821. We write the law PV equal to nRT, so volume is equal to nRT divided by P. We replace the variables by their values, and we find the volume it's equal to 10 liters of carbon dioxide. If you still find it difficult to solve stoichiometry exercises, you may find useful links in the description box. And now you are ready to solve the end of video questions. If not, repeat the video again. If you find my videos are useful, subscribe to the channel and hit the bell icon to get notified and watch the new videos. Don't forget to share this video with your friends and write me a comment. Thank you.